Alright guys, hello and welcome to Ms. Sosa's math class, and now online. It's truly learn at your own rate, participate in class, math class. We're going to be going over transformations of quadratic functions. That's what we were supposed to be learning this week. Only that. You guys may have seen some graphs. You might be asking, why should you care about this? When are you ever going to use it? I might have just ignored you in the past, but specifically, I don't know what you're talking about. Life, logic, mathematics. I can't just read your mind. But we're going to discover this new topic with things you already know, like domain and range. Let's start there. What is the domain and range of this graph? See, so pretty awesome. You already know what a quadratic function is, or the domain and range of a quadratic function. Basically, a parabola, this U shape on a graph, is a quadratic function. What it does is, in algebra, allow us to create the square from geometry, because back in the day all they had was shapes and they couldn't think in abstract terms like x's and y's to represent things. They needed physical objects before their mind could develop into realizing and understanding these abstract concepts we call numbers today. So, that basically the parabola is a algebraic representation of the square or rectangle or whatever you want to call it. And graphs have an advantage, I think, over the traditional computation part, the data, because it allows you to see all the numbers at once and what the function's doing and how x and y is increasing. And maybe you need the data sheet for a specific moment in time, but right now we're not really that concerned with that information. All we want to do is understand how to read the graph, and for most people the graph I think will be a little bit easier to understand all these concepts. Don't be scared of the graph. All it is just a whole bunch of numbers represented by a line, and once you understand that and can accept that you're looking at more than just one number at a time and you're seeing the bigger picture, I think you can then finally appreciate the calculators and what's going on exactly. So I don't have to do all that tedious math stuff. Anyway, a lot of you guys might be wondering, what are we going to do with these weird measurement things? When is this ever important? I can just measure a square or rectangle or whatever with a ruler and figure it out. It's not that hard. Slash, I'm going to pretend it's hard so I don't have to do the work. But math is kind of in everything, and it's just so beautiful and amazing. So if you think about our cell phones and the way we use light, actually the algorithms that decide what color they're going to put on your cellular device from the picture that you took comes from quadratic equations. If you remember lights on a spectra, and there's a data chip in the cell phone that somehow collects the light through sensors, and then it'll measure the like electron voltage of the particular ray of light that's bouncing off of some other object that is the color that we perceive it to be. And then depending on where that graph intersects the um, x-axis, that's how they determine what color it should be, what hue it needs to be, versus when they like input it in a matrix calendar and compare it, like how black it needs to be, how blue, how red, green, um, and it just makes this cool thing. So after all that stuff happens, maybe you're taking it on Instagram or something, and every time you use a filter, basically what you're doing is shifting the colors to show, you know, the lens or viewer what they want to see. So after you've taken the image and you've recorded all this information, you can then shift to these graphs and change the output that the phone is going to give you. It doesn't make sense to start changing the mechanism inside the device, but moving the inputs is a simpler way, I guess, to make a beautiful output, if that makes sense to you. But let's stop there in our conversation of why you might need this. And let's talk about some of the shifts and things that are happening in our graph and just answer some questions. These things should be in your notes. You're awesome. You're wonderful. Have a great day. Just ask me for help if you need it. Okay, bye. What could this one possibly be, my friend? Domain and range. Domain and range. Da da da. Transformations, photographs, math.